Right, good evening everyone. I hope you're all doing okay. We're back for more live streaming with the V-minion. Not particularly a sponsored stream today, this is just like me doing more stuff with the V-minion, but I'm going to still talk to you about the divider PCB and stuff like that. Because they're my things, and I think they're lovely. So the plan for today is to do a little bit of like configuration-y stuff that I didn't do for like fine-tuning and things last time. In particular, another one of my things, the calibration flower for like skew and stuff. As you can see, I've already printed it. Probably going to do pressure advance. I might not bother. We'll see. The ADXL, so we can do the tuning of the vibration-y things. Forget what it's called. Resonance compensation kind of thing. We'll get the right name at some point. And then hopefully do some speed benches afterwards to try and see if we can beat the V0. Good evening, good evening, good evening, good evening, everyone. It's weird how the live count goes from like 26 people waiting, I start, and now it says 15. So when I press start, 10 people just left instantly. They were like, nope, don't want to see that, I'm off, bye. Anyway, that was the plan for today. So, the first thing is this. If you haven't seen it already, this is like a calibration print that I made. The premise is it's just a bit better than doing like a calibration cube. So the idea is you print it on your printer in whatever materials and settings that you use, and then you measure it with some calipers, and I've already printed it and I've already measured it. So I just wanted to show you the results because it's not only can you like calibrate your printer with it, but you can kind of tell how well it was assembled. So my thing is normally a Excel document, but this computer does not have Excel. So the alternative is I've taken a screenshot and I'll show you that. So these are the results. You do each position. So there's like some outer positions, some inner positions for X, and the same for Y. And there's like some 50 mil and 100 mil. So you get a good variation of measurements in both directions, and as well the two skew diagonals, which is like this way and this way. And then you measure them all and it gives you some results. So as you can see, everything's in green, so less than 1 mil deviation, which is good. And they're all really, really quite close. Overall error is absolutely stonking tiny. This is the kind of results you would expect from something you've already calibrated. And I haven't calibrated it, so that's pretty amazing. As you can see, skew also super duper low. I could probably get away with not adding in any skew compensation, but we're going to put it in because then we've done it. Annoyingly, it comes up with this password message each time, even though it doesn't need to. So, let me just make sure I share the right windows. So, hopefully this is V-minion, this and this. The password thing is quite annoying. I don't know why that happened. So, back to here. The idea is I've added in these like little fields where you can just copy and paste the stuff that you need into your configuration file. Now, I've not tested. What on earth is going on? Ultimate Cura has just randomly decided to launch. Go away. I did not ask for you. So what we need to do, and now this is going to keep coming up. I should have just imported it into Google Sheets. That's the easiest way to do it if you don't have Excel. My VCore 3 ones were the ones I used in the video, so quite a long way off. Assembling that printer really square is quite difficult. Where are we going? No. Print it? No. I did the updates between last stream and this one, so I had to, yeah, there were some issues. Well, not like issues, I just kind of did it wrong, I think. So, and then what else happened? Because I had to remake the config file. Oh yeah, I just wanted the corrections in it, that's all. No big deal. This is going to keep happening. In here, I don't know if there's a skew correction already here, but commented out. Let's have a quick look for it. No. So we're going to add it in manually. So we can just copy and paste it out of here because that does the same thing. Oh, what? No, come back. Skew correction. You don't actually need any parameters under it immediately. It just like enables it, the module or whatever. And then once you've got that, you can, from the console, copy in this. So this bit of G-code, this console command will enable the skew determined by the parameters that I've measured. That's set that skew, and then we can save that skew profile. I'm just going to use the default name because it's easiest to do that way. And then, oh, I should put the save config in there as well, shouldn't I? But we save that. That should restart. And then we have to add the loading and clearing of the skew profile in the start and end G code. Machine. Do we have start and end G code in this? That's the question. We don't. So we're going to have to do, there you go, there you can see it's loaded the skew profile. We have to copy it from the original location and make a copy of it in there. Question is, where is it? Macros. Separate macros. So is there, I believe if you edit it in here, then when you do an update, it will get overridden. So you don't want to do it in here. You have to copy this into your main thing. Unless there's a better way. Is there an automated way? Let's see. What was this? Skew profile to load before starting the print. Uncomment this to use your calibrated skew profile. Variable skew profile, my skew profile. Okay, so yeah, we'll just define that profile. Oh, hang on. Variable skew profile, my skew profile, that's the default name. And then that'll do it for us because it's RatOS. So that adjusts the skew. If we want to adjust the XY offset, we can do that for materials, and that's something you can do in your slicer. But for the skew, you need to do that in your, either in the firmware or this configurable firmware. Can you run an ERCF on a Rat Rig V-minion? I actually don't know. I've not looked into the ERCF very much at all. So that's all we have to do. I mean, we could do this as well, but this is so blooming close that other materials are going to be more of an impact than this. So I'm not too worried about that at all. Just we should have refined that skew a tiny little bit. So that's item menu, menu item number 1. Check that one off the list. That's calibration flour. You slipped in the line while uncommenting. Pretty sure I corrected it. We'll go and have another look. Variable skew profile, my skew profile. That looks fine. You can see it's down there. So you could name it a different profile, but I mean, typically I only ever want one, so whatever name it is, doesn't really matter. The other thing I want to refine is the Z offset, because it was not quite right. Because I changed the bed surface. We'll change it back to the texture one. In fact, we're probably going to be printing ABS mostly today, so I think we'll probably go textured. I've been using, for printing PLA, just the Prusa PEI, the smooth PEI sticker sheets. I've had this one obviously from the Prusa Mini when I got that. That was a little while ago now. So we don't need to do that. Pressure advance, I don't know if I'm going to do that. There's not a really quick way to do pressure advance, is there? And I think there's already some like pre-tuned values in there, which are pretty good anyway. We'll have a look. Let's see if I fancy doing it. Slicer, I think it's in here. No, initial configuration. So PID we've done, pressure advance tuning. Oh, shit. Sorry, can't say it, can you? There we go. Pressure advance does 2 useful things: reduces ooze during non-extrude moves and reduces blobbing during cornering. Use a slicer to generate G-code for the large hollow square. 0 infill coarse layer height. Make sure any dynamic acceleration control is disabled. Prepare for the test by issuing the following G-code command. So we need this file. And we're going to put it into Super Slasher. It says, good idea to read this document in full. Use a slicer to generate G-code for the large hollow square. Use a high speed, e.g. 100, 0 infill and coarse layer height. So, I just realised this is on 0.6 nozzle. Let's get rid of this. We don't want this anymore. I don't want this either. I've already, in fact, it's a 0.6 nozzle at the moment. I need to change it back to 0.4. Or no, have I already changed it to 0.4? I think I already changed it back to 0.4. Yes, it's at 0.4. I mean, the tower was just suggested, which is why I'm going with it now. I think it's easier to see the effects in the tower than it is in just the printed rows. Right, let's make a new printer. Hopefully that should work. Okay, so all default settings. I have already, by the way, changed the stepper driver configuration. So there's 2 stepper driver configurations available. There's like the uncooled and the cooled version. It suggests using the uncooled one until you know that everything's working correctly, which we kind of did in the last stream. And obviously I've done some stuff a little bit recently. Between then and now, I mean. So now I've enabled the performance mode. So unlocking a bit more speed. Maybe we'll just not bother with pressure advance today. Seems like an effort, doesn't it? Well, we'll do it. It's quite a long print as well, isn't it? How long is this print going to take? My mouse is jumping all over the place and it's kind of annoying. So we've got the cube, coarse layer height, print settings. Looks weird. Zero infill. Speed. Those are pretty speedy speeds. Layer height increase to 0.3. Make sure any dynamic acceleration control. I mean, we can search for that. I'm not sure what it's called in here. Oh, this is acceleration control. So we put that to 0. Oh. Yeah, we can probably reduce the bottom layers. No, top layers. I don't think we need any top layers, do we? 3 bottom layers, have we got no infill? Yeah, so that's going to go slow. Cooling. So I might have to get the big fan out. I think that should be everything. I think these 5, 6 settings is those. Machine limits, acceleration. Time estimates. Okay. So before we send it to the printer, let's send this. So prepare, then this command makes the nozzle travel slower through corners to emphasize the effects. Then for prints with a direct drive, run the following command. Bop, bibbidi bop, boom. Then print the object. When fully printed, the test print looks like this. Okie dokie. Yeah, I've done 0.3 layer height. That is in there. I know the PyFile file says 0.2, but I've modified it to 0.3. So this is PLA cooling. Okie. So that's going to be printing for a little bit now. I might need to get a fan out, we'll see how it goes. If it just goes to mush, I think we'll just do it another time. Or probably not bother, because I don't, well, it does have an effect obviously. But a lot of the time it can be kind of accounted for by just doing designs where corners are not as important. Pressure advanced tuning, input shaper. Skew correction. Skew correction we've done, so the input shapering is the last thing. See the wiring diagram for your board. RadOS primarily uses an SPI connection on the MCU itself instead of the Raspberry Pi for ease of use. Some printers may require more than one ADXL, and in that case a config for the ADXL345 connected to the Raspberry Pi is also available. If you want to use an ADXL for automatic input shaper calibration, all the software you need is already pre-installed. You just need to wire and map the pins for your ADXL345 and you're good to go. To enable resonance testing, uncomment the ADXL include section at the top of printer.config. To verify the ADXL is properly connected, write measure access noise. If the values are below 100, you're good to go. To calibrate input shaper, write shaper calibrate in the console. Do you adjust for the different height of the bed? I hadn't adjusted for the flatbed, so it's already pre-adjusted for this one. If not, I'm here and can adjust as we go, but it should be fine. So I would rather not have to create a second wiring harness for a second ADXL, although you obviously need two to be able to do this. Well, previously I've just done one and then the other one, which seems much easier. So I think we can just add an argument to the shaper calibrate command, and then it will just do one axis at a time. All we need to do is make sure we're wiring this doohickey up to the right thing. So might get some just little wire extensions maybe. Whoop. I've got the ADXL here. I have a pre-made little harness thing for the ADXL, but every time I use it, it seems to have different wiring setups. So as much as I can try and prepare, everyone likes to do their thing a little bit differently. Just use some of these DuPont like pre-terminated little ribbon strips. These are quite good for just connecting stuff for short periods of time. There's this wiring diagram. It's kind of confusing. I'm not sure what this green marker is. 1, 2, 3, 4, 5, 6 wires around this interface. Red, yellow, green, orange. Red, yellow, green, orange, blue, and brown. Green marker is to change the jumpers. I don't understand. So something on the hello. So I've changed the power supply fan, you might have noticed already, but it still does come on. Just not all the time. These 2-port connectors have been absolutely mangled at some point. Wasn't me. That one was inserted the wrong way around. And one of them, the connector's just all bent inside. Oh, jumpers on the little, not across the wires. It looks like they're attached to the wires. No, I see. Okay. I see what they're doing now. So we just got to kind of wait for it to print. Super duper slow with weird acceleration settings. So I finished off the final documentation for this today. Well, the production revision. So version 1.4 of instructions. Got some nice photos of all the final production PCB and design and everything. Super duper happy with that. So if you want to check them out there on GitHub, anyone can have the instructions. They are openly available. Check Nero's YouTube's creating a Pico ADX hub. This is not Pico control board, but it's fine. I should be fine. I've been calibrating my pressure advance at my actual printing speed lately, and the result is lower and more accurate when printing at those speeds. Yeah, definitely printing, doing the test at your printing speed would make sense to me. This is one of the things about calibration, like if you're going to calibrate it, surely you want to calibrate it to the state where it's most likely to be. Like if it's going to be running high speed the whole time, do it at high speed. If it's going to be running low speed the whole time, do it at low speed. That way you get the calibration then reflects the real life results. It fits an ADXL to a Pico and USB to fit into any printer with clipper and spare USB. I guess this is because... Oh, where has it gone? Yeah. Ground VCC is 5 volts, and then it's just CS, SDA, SD, SDO, SDA, and SCL. So you power it off one and... I mean, I prefer normally to do it on the Pi. This cable's set up to do it with the Raspberry Pi. Maybe we'll do it that way, save me having to fiddle about. I think it's set up for Raspberry Pi anyway. Beware that there's a variety of different PC board designs and different clones. You need to connect to your Raspberry Pi via SPI. Why does it think it's 19% complete already? Raspberry Pi MCU. Touch, homing, input shaper. Uncomment the following line to use a single ADXL 345 that you manually move between the X and Y axis. Use shaper calibrate X and shaper calibrate Y respectively. Uncomment the following line to use dual ADX 345s, one for each axis, so you can permanently attach and wire them to your printer and run shaper calibrate once. Yeah, I think this is... Why would you ever permanently attach? It's just a load of wires you don't need. The second ADXL should be connected to your Raspberry Pi. See the wiring instructions here. Note you only need to wire the ADXL 345. Everything else is already done for you. Alternatively, check for manual input shaper calibration. I want to use a single one on the Raspberry Pi. V-minion, input shaper single. Let's go see what these are. Are we back? The YouTube warning. The current stream bitrate of 6,000 kilobits per second is lower than the recommended bitrate. We recommend you use a stream bitrate of 4,500 kilobits per second. Well, strangely enough, 6,000 is not lower than 4,500. What a weird way to cause a problem. YouTube is drunk. Tom, happy birthday! Everyone wish Filament Frenzy happy birthday. Does the max 60 watt for the heater come from the printer mainboard or your PCB or connector? Does this still apply with an external MOSFET? So you could, on the PCB, you could probably actually go a little bit higher than 60 watts because the connectors, terminals, bed, like PCB traces, are all the same for the bed and the nozzle, the hot end. So you're probably pretty safe to use both.
Go beyond subscribe.
Oh, a Raspberry Pi Pico, not a Pico Big Tree Tech Pico. I don't have a Pi Pico, so... Oh, that's just, yeah, that just like is creating a portable accelerometer rig. Yeah, that's a good little idea. But I don't have a Raspberry Pi Pico, so... It's weird, isn't it? It's so cheap, but because you only use it like at the startup, you really only need one. I bought a couple of spares just because, you know, spares, but... I think what I'm probably going to do is enable the configuration for XY, because this is just going to include the libraries to do it on both, and then I'll just run the normal command. I don't think there's a reason why you can't run shaper calibrate X when it's logged into Raspberry Pi. Didn't expect both, but we can just move it, hopefully. Oh no, this is saying for X it's Raspberry Pi, and for Y it's there. Whereas the other one is saying the acceleration chip is there. So what I'm going to do is, where is it? Let's check that my wiring is correct first. Installation, so yeah, it looks like it's set up for this. I'm going to have to continuity test. When I made it, I used all black wires, which looks nice. It means you can't see the wires at both ends, so you don't know what's plugged in where. Yep, that looks right. Just SDA. SDA is yellow. There should be this one right below the red. Yes, okay. So I'm going to plug it straight into the Pi, and I'm hopefully going to be able to configure this sensibly. Just got to make sure we plug it into the right place. That's the downside of using these like random headers in the middle of the 40-pin array. Just making sure you plug it in the right ones. So I'm going to go add a bit of code to the bottom here. Oh, that's not what I meant to copy, was it? Forget that. Where is it? Config. Let's just open and modify it as we go. Config printers, V-minion, input shaper. So this is one version. And this is the other version. So we want to load this, we want to load this, and then we want to say both chips are on the Pi. Everything else is basically the same. So let's just take that now. Oh no, that's macros. One more, printer. I'm going to go put these at the top, just so we... Oh no, you don't really have to. We'll leave them there. This is a very exciting print, isn't it? Absolutely thrilling. Such box. What else can we do? Fiddle with while we're waiting. We need some screws for mounting. Now, because I've used my own like modified tool head bracket thing, I know that my ADXL will fit there, but I think for the one on the bed, my one is a slightly different design, so it won't fit. I'm just going to use one screw and hope that that's enough. It should be. Quite like a nylon washer though, maybe to... Don't think it came with any. I think there was a mod actually to do with ADXL, but I've not printed that, so I think a single screw is probably enough for the direction it's going to be facing. Shouldn't affect it too badly. Come on, Mr. Printer. I've got an idea. Shall I make a discount code for anyone that's just going to work? That could be fun. Can't really do it on this computer though. Oops. Just like you, thank you for the photo of the back of the vehicle. Has helped me know when to do the electronics. Can read photos better than. Good stuff. I'm glad it helped. Maybe I should send more photos and stuff, because maybe that will help other people too. Anybody got any other questions? Did I, for some reason I have this memory of buying a Pi Pico. And now that it's been mentioned, I feel like I might have one, but I don't remember. Sometimes, if I want something for a project, I'll like buy it and get it to come, but then it'll end up being delayed or missed or something. It'll be too late for me to actually use, and then it arrives and I'm like, I can't remember why I got this. Pi Pico, it seems like one of those things that I might have bought for a thing and then not being able to use. I can show you this. I made this little like box thing for a photo backup project. There was an open source project for photo backup using a Pi Zero. So I created this nice little box. I was going to end up like trying to sell them as like a little product or something. So it's just like stacked things, Raspberry Pi devices, like one on top of the other. I never ended up selling them, but I keep this one as like a, I don't know, a memento thing, I guess. I used it for myself a few times. Used it for myself a few times. But I think there are better options available now, which is why I ended up not going ahead with it. But so it's like just multiple stacks of things upon things upon things. How easily did this go in? I forget. So it's like this Pi Zero, and this, and a hat, and a screen. It's just this little dense little box of stuff. Come and look at this. So in all of here, I think this goes on here or something, and then this goes in the bottom, and it's just pogo pins that just go up to the bottom of the Pi, and it just forms this nice little stack. Little Pi Zero. Ooh. Anyway, you're not here for that. You're here for printing. Here's the printing. I think this is probably too boring, and I think it's probably done, so we'll get this back in here and finish that off. Nice. Oh yeah, that goes in here, somewhere around. I forget which way. That way. Then there. This fits nicely in here. Can you come round and sort out the crimping on my vehicle? Nah, soz. Sorry. I don't really enjoy crimping. It's one of those things that's a necessary evil. Would it be possible? Oh, it doesn't really seem to be going faster every so many lines. Is that my imagination? Yeah, it doesn't seem to... I don't think it's meant to go faster. It's meant to change the pressure advance, which it is doing. But I'm honestly bored of it, so... Nice. So if you look up close, hopefully, if you can see this front corner, nope. You can see how it's like bulging down here, and then you've got gaps up here, which means somewhere in the middle is probably the right amount. And then you measure that with calipers, how high that distance is. Let's zero them. Which for me is somewhere around 11 millimeters. So if you go here, pressure advance, tuning, do the thing, do the thing, do the thing. Pressure advance will then be calculated. Pressure advance equals start plus measured height times the factor. So start was 0, and measured height, which was 11, 0.005. Oh, 11 times 0.005, which is of course 0.055. And I think let's do a quick restart. Oh. Oops, I made a boo-boo in that configuration. This bit I added in. Didn't like this for some reason. Maybe we're going to be using the original configuration after all. Hang on. I just want to save it because it's hot. I want to make sure the fans keep going. I don't know why. I suppose when it can't connect, it can't tell the fans to turn on. there's another problem. What have I done? What have I done? Okay, let's at least pull the filament out. Cool. So if we did this, a bit shaky. So we use this version. See what that does. I always press the wrong things. Printers, V-minion. Close that. Oh, I've copied the wrong thing, I think. That's the one I've already got. Config. Config. Printers. V-minion. Single. That's directly to the control board. This is with the Pi. Doesn't like this. Oh, because that's based on the child path of this or something, isn't it? That's why. Board sensors. It's not within here. This is where macOS becomes more complicated. I think it's going to be easier for me to just do it the normal person way. I mean, it is suggested to use a single one like this. So we'll do this one. So let's go back over here. Where are we looking now? Electronics. We need this diagram. We need our box open. Which way? I think this way is the way. I did the first print on the weekend. Wasn't it? Or Friday last week? That's the printer. So we're going to have to run all this ADXL stuff with the printer open because of the wiring reasons. So it's this area in here that I've got to connect everything to. And once the jumper's in a different position to what I have them. So, okie I think we need some tweezers. Run some across the top 2 pins here. And for this one too. There we go. And then I'm going to have to do some rewiring. Just going to use these. So, first thing to do is we can connect. These wires now will all be the right colour apart from brown, which will be black. So if I connect them to this header according to the clipper instructions. So red is obviously to red, yellow is just below red, green is just below yellow, and orange is just below green, and then blue is adjacent to orange, and ground is the remaining one. So now we have 6 coloured wires that are correctly coloured. Hopefully the same wiring as this. Yep, okay. So now we follow the rat rig diagram, which puts black up here and blue just below it, and red top on the other side, yellow below that, green below that, and orange below that. So that's our wiring setup. And then we've got to plug in the actual sensor. So we'll do X first, I think. I think that will be slightly easier. Yeah, I just tried to do the Pi configuration for it though, and I couldn't get it to work quickly, so I could have done if I spent some time faffing about, but I didn't like faffing about, so I didn't do it. If I was using like standard firmware, I think it's easier to reconfigure. But when you're using RatOS, if it's not exactly how you want it already, it's a bit more difficult to modify. Because of its modular nature, there's stuff kind of organized but in lots of different folders, which is really good for people that don't want to modify things, because it's all organized for lots of different configurations already. But if you do want to modify things, it's not quite so simple. So that's connected to there, that's connected to there. Let's boot her up. Absolute silence. Lovely. See the wiring diagram for your board. Some printers may require more than one. All the software you need is already pre-installed. To enable, uncomment the ADXL section to verify measure axis noise. So what we should be able to do is paste measure axis noise in here. Just in this. We should, there we go, should be less than 100 for all of them. Yes. And in this orientation, X, Y, and Z are the real values. Weirdly, this is not 9,800, which I thought it was meant to be, but maybe it's compensated. Okay, so that looks good. To calibrate, shaper calibrate, but of course we only have X, we can't do both at the same time, so we need to go to printer CFG, just double check what the command was. Use shaper calibrate equals X, copy that. You can just type it out, but you don't make a mistake if you copy it, hopefully. I think we've got everything prepared. Let's just double check. Mounting, software, that's all done. For non-bed slingers, do this. For bed slingers, do this. You should see values. If you get an error, do this. Next, try running measure axis noise and Octoprint. You should get some baseline numbers for the noise of the accelerometer on the noise values, not the absolute values. That's why it wasn't 9,800. Too high axis noise, 1,000 or more, can be indicative of the sensor issues, problems with its power, or too noisy imbalance fans. Measuring the resonances. Now you can run some real-life tests. Run the following command. Test resonances X. Okay, so that's just a run you through it step by step. We're going to do auto, and this should just do it. Must have axis first. So we're going to raise this up a little bit. It's probably good. And right. Oh, it's going to set its own position. Okay. And it's off. Do the vibratory thing. Obviously, it goes up to a reasonably high frequency, so after a moment you won't see it moving anymore. But it is, in fact, still moving, like magic. It's very, very noisy. As random things around the room start to vibrate with it. Sounds like there might be a loose screw or something on the hot end. Something is really not enjoying the process. Might just be the fans. Oh, there's another one. It's gone again. 100 hertz now. So that's finished its thing. Waiting for calculations. Calculating the best. Spamming some results. We'll save this. So, high acceleration recommendations, which is good, but that's the X which you would kind of expect. So 9 to 12 and then 1 at 17. It's pretty good. So now we home again. And we repeat with the other axis. Oh no, just where I hadn't started. We need to obviously move the sensor. Because if you don't move the sensor, you're not going to be measuring very much. So there's an intended position for this down here. Probably can't see it very well on the camera. There we go. There you can see it here now. The unfortunate thing is mine doesn't fit this whole pitch. It might. No, it doesn't. So we'll just have one screw and hope it's tight enough and holds it appropriately in place. Yep, that seems nice and tight. I'll leave the camera at this angle because then you can hopefully see some bed motion. At least at the start. So pretty much the same command, but with the axis equals Y. Off we go. Invalid ADXL345 ID got 0 versus E5. I don't know what that means. Does it mean I shorted something on the thingy? I printed last week. This ADSL is just generally terrible. There's no protection around the holes, just like when you screw it down it just mangles the copper traces. We did a knot, Mikkel's not a cube. It was okay, but we did like a 0.4 profile with a 0.6 nozzle, so Okay, accelerometer is reading now. Here we go. We're off. Yeah, so if you're doing a Cartesian that has separate X and Y, or even if you've got belted Zs, maybe you would, I mean you probably wouldn't because you don't really do anything fast. But yeah, if you have independent moving axes, you can either use two sensors, you put it one on the X and one on the Y and run it both simultaneously. Well, it kind of does one after the other anyway, but then it's one command. But if you just do what I'm doing, you can move the sensor from the carriage down to the bed, and it's just as easy pretty much. Because you don't need the ADXL during printing. There's no feedback loop or anything. It just measures the response and implements that. So you just get one sensor, wire it up just temporarily while you do the testing, and then unplug it. What speed was that printed at? Default profile. It was the Rat Rig V-minion profile, but also with the like the extra basic motor settings. Whereas I'm now on the fast high power motor settings. "7 feet of cable. Why is your x-axis so far from the control board?" Yeah, it was pretty slow. Oh, there we go, up to 133 Hertz, and so we're done. Second screen, what are the results? Oh. Calculating 9,000, 7,500, 7,500, 7,500, 7,500. Nice. Again, save config. Right. So we can now remove the sensor. Putting these screws back in just so the nuts that are in there don't go loose and wobbly. I can't remember if we would want input shaping on and off for doing a speed benchy anyway. So that wiring should all be good. It's almost tempting to leave those wires attached. And let's assemble this printer, what's it back together. Right. We do need to change the nozzle. Oh, did I do all of that with the wrong nozzle? What nozzle have I got on it? There's a 0.4. We need high flow 0.4. This is what we need. We've got a the Bondtech nozzle, forgotten what it's called. CHT. The one with the split flow path. Which is the same, is literally exactly the same nozzle that I had for the V0. I've removed it from the V0 and I'm putting it on here. Ain't nobody affording two nozzles. Right, let's get this bumped up. Oh, this is going to be a pain to put back on, isn't it? Like this. Should be able to do it kind of cold. Oh, that's very, very clean. I must have got a really good pull off of that nozzle. I did. Holy bananas. Well done me. Can see right through that. Anyway, stop patting myself on the back and get on with it. This should be 0.4. It's a bit mangled, but the important bits are there. Unfortunately, for some reason, they use a weird size hex on the CHT nozzles. I don't know if it's a Bondtech thing or if it's a something else thing, but they use a different size. Grippy things. Is which this small pipe pliers is not, this is Nipex. This is another really expensive brand. I tried to put this on the wrong way round. Yes. Right, are we there? Big boy nozzle. Now we need a big boy filament. We need some ABS. PLA is not going to be enough. Choppy things. That's probably an Imperial adjustable spanner. It's the only Imperial tool I've got. Cross compatible though. ABS, where are you? I don't know if I have any good green ABS. In fact, where is all my ABS just in general? I've lost it. ABS is disappearing. Oh no, here's white. Maybe not ideal, but it'll work. Hopefully. That's right. What's that? Giant spools. This is a small spool. If you want to see a giant spool, this is not even that giant. This is just a 2 kilo spool. I need to try and find some like 10 kilo spools and put that. Right. This is just a normal 1 kilogram spool. It's cardboard, so it looks wider because it is wider than most plastic spools. But it is just a normal 1 kilo spool. Loads of places sell 2 kilo spools. Generally places that have industrial clients, like in selling to like other businesses that produce from like farms and things, they tend to sell larger spools. They also tend to have fewer colours. Somewhere like Filamentive, they have 2 kilogram spools, I believe. Don't quote me on that, but I think they do. If you look around, they're reasonably easy to find. There are places that do like 5 kilogram, 10 kilograms. They go massive if you look in the right places. Right. We need to preheat ABS. Right, so, sorry, just setting things up, ready to go. I think we'll be testing out. So I used a V0 profile, here we go, second screen. So, this is the profile I had for the V0. And I think what I want to do is copy this somehow and merge it with this one somehow. I wish there was just like a merge feature. I suppose yeah, it doesn't really work, does it? Machine limits, extruder 1. So we need to save it, change the bed size, change the custom G code. So we want the V-minion custom G code. Should just be end print. Yeah, that's fine. Oh, wrong one. I'll do this before layer change. Okay, and we also need to set one 180, 180, 180. It's not really matter too much the volume because where we print it's kind of irrelevant as long as it's on the bed. And then print settings we should be able to use speed profile, ABS speed profile, like that. Weirdly, even when you have all the 3D Benchy files, you search 3D Benchy and it comes up with literally 3 of like 40 results. How is Windows such bad search tool? So, second screen, that's our Benchy. Slice. So should already have some of our pre-configured helpery things from last time. I think this was our super fast. 8 minutes, that's quite fast, isn't it? Can't remember what the rules are. % infill. Speed. Oh, so this was my slightly dodgy one, I think. .25. I thought it had to be 0.2 layers for speed Benchy. Let's try this one for now. See if we can get you with this. $31. I think it's going to be a bit over the top. We've still got 3 parameters. So let's change this to the minion speed with 3 E's. 2 parameters, 2, 2. This is 0.25 layers as well. Skirt. Don't know if we want a skirt really. This filament, the cooling settings should be fine. Yeah. Because we've got super hot settings, same as before. Chamber we won't have, so hopefully it won't wait for that anyway. Right, we might not make this, we might. I really don't know what's going to happen. The only thing we can do is have a go. We need to make a printer. So we can send it to Clipper. Okay. Slice. There you go. And switch to camera on this one. It's received the print, it's heating the bed up to 110 C. Things are about to go bananas. The motors are stonking hot, ready to go. That current hold is just insanely high. Current hold current. 109. I think the temperature of the nozzle might wait. Yeah, it's going to wait for the nozzle to cool down weirdly. I think. Oh no, we're going to go. I have no idea what the currents are. They're just the default currents on the performance profile. We'll see if that's going to be sufficient in a minute. It might go kaput immediately. It might just go and not manage anything. That's when we know we need to increase currents. I mean, the speed it moves the bed just for the blowing leveling is fast. This long leveling process is making it such an intense wait. Yeah, PLA doesn't stick very well to textured surfaces, I've found. Smooth is best for PLA, smooth PEI. Limit will beat LGX Lite. Hardly pushes. What on earth are you doing? I managed like a 4.5 minute Benchy with an LGX Lite. It pushes pretty good. I don't know why it goes up like that. Cool down to 150 on the nozzle, now it's going back up to 260. And when it gets to 260, it's going to go full chooch. Whatever chooch means. Maximum go. $210, $220, $230, $240, $250, $255, $260. Couple of seconds to balance out. Off we go. Off we go. Off we go. Let's go, 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 let's go. Oh, that's a very chill prime line. Hello. That's a very slow speed. Hello. Okay, so I think this is where we need to increase the machine settings. Acceleration is at 7,000 at the moment. Layer 1 speed. Did I set a slow layer 1 speed? I might have done, we'll see in a second. Oh, I forgot to press start. For some reason the acceleration was on 7K instead of 15K. Something's not right, is it? I mean, we're going to get faster and faster. Remember, the settings for this were 28 minutes, which is pretty slow. It's doing some quite insane acceleration moves, but I think it's peaking at really slow top speed. Or it might be the corner velocity is at 5 millimeters per second. Normally I have that much higher, I believe. It's so slow, isn't it? Why is it going so slow? It's not minimum layer time. I'm using the ABS speed profile, which is the exact same one I used before. Layer time goal is 0 seconds. It's doing some really weird, extremely fast acceleration, but I think the print settings are just too basic. Right, we're gonna, I think it's not requesting a fast enough speed for some reason, so we're gonna boost the speed to like 200%. Ooh. Made a weird noise, but I think that was a deliberate noise. Yeah. Maximum flow limit is a filament setting as well, I believe. Maximum volumetric speed is set as 0. It was the weird profile I used. It looks like I didn't actually save my profile from last time. Yeah, the max volumetric speed, it's all... It was just demanding the wrong speed, that's all. So seeing as that's going to take a while, I'm just working on setting all the speeds at 500, removing that acceleration override. That was having an effect as well. I think maximum print speed is going to match whatever this lot is. So if we save that, that should be faster than 28 minutes. And you can start to see speed is looking good, but we've got some slow top layers for some reason. Is it top layers? Solid infill speeds are 90. Okay. Oh dear, where have we got this? You get some really epic warping, that's for sure. We've got to be able to print our Benchy in less than 8 minutes, purely because otherwise it will remove from the bed. We might have to put a little brim on it. Skirt and brim. No skirt. Brim width, 1mm. Try and give it a little extra. I don't know where I can put that it doesn't interrupt anything. Right in the middle. So that's 500, and then we can control the machine limits more from the printer maybe? Official speed Benchy is no brim. I'm using maximum part cooling. Part cooling fans on 100%. %, 250%, 180 odd millimeters a second. She really goes. Why is it in green? Because I changed it to green. You can change it in the settings. Somewhere. UI. They used to have like a themes thing, but themes seems to have gone in exchange for just colours. Square corner velocity, I think I had 125 or something for the V0. I suppose I should change it to match the printer, shouldn't I? That would be a logical thing. Oh, found that quickly. Yes. Never do that. Never put your fingers by a moving printer. Your printer's by a moving finger. I mean, if that sticks to the bed for the stack and everything, I'm going to be amazed. I don't think more velocity is going to change anything. Increase accelerate. Ooh. $19,000. It's going pretty good. I mean, I'm amazed it doesn't just shoot off when the bed stops moving. It's accelerating and decelerating so quick. That alone should cause it to fly off the bed. Zip, zip, zip. Zip, zip, zip. That's a good question. Can someone go and check my V0 video? I don't actually know what the target is. 48mm motor on Y. I think this is the standard one, which I think is 42. Yeah, we definitely got some extra chooch in this still yet. The faster prints will definitely go better. They'll stick better, I think, because it will apply so much heat in those first layers so much faster. For this print, remember we were very slow on the first layers and the cooling was at 100%, so those first few layers were just, well, they had all the heat sapped out of them, which is why it's probably warped so much. Yeah, I think it was 5 minutes if I remember correctly. I think if I try to start and watch a YouTube video to check though, my computer's going to die. Oh, there she goes. Whoosh. So 14.5 minutes for not a Benchy. But not bad. Not bad. Reasonable quality for 14.5 minutes. I mean, it's not finished, but it's a half a Benchy and double the time. But apart from that, it's fine. Right, let's keep it preset to ABS. So next one is targeting 12 minutes, but should be much faster. We can set let's reset the speed. Reset this. Right, we go. Go, 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 go. Oh, don't change this back. There we go. What filament is it? This is Ooze Nest ABS Snow White. Ooze Nest have a huge range of filaments, by the way, ABS. So many colours. If you want a printer in a weird ABS colour, that's a pretty good place to go. Show off his ABS. My abs. Good abs. This is white abs. Printer is made of purple abs. Thanks. It's better than the stream on Friday, isn't it? That was a mess. I was well overdue a haircut. I'm being attacked by network cables under the table. I really feel like I need to be eating pizza while I do this. Just feels like a thing. Takeaway pizza and speed benches. Zippity doo dah, let's go. I don't find local PDI sheet. I found 260 large Kapton tape. To give it a try, I have some problems with SA. If it sticks, it warps. I'm not sure quite what the question is, sorry. Kapton tape is quite good, actually. It used to be used a lot when like the only materials people printed in was PLA and ABS. And it got phased out for some reason. I think it was a pain because it came in rolls that you had to like stick on. OSEC do some great print surfaces. They sent me one quite a little while ago for my Prusa. That's where it is. They have this like hot surface, like safety tag on them as well. It has a little mark down here that goes bright red when it's hot. Well, anything over like 40 or 45 degrees, something like that. Whoa! That's a bit quicker. Holy ball of bananas. OSEC do quite a good range of sheets actually now as well. They only had a couple to start with, but now they do quite a few sizes. Did you clean the bed before it? Do you want to? No. I'm not sure cleaning the bed is going to make much difference. When you see how bad the print quality could be, this actually looks quite good. Oh my goodness, how fast is that? Jesus. Five minutes 33 is the time to beat. Ooh, that didn't sound good. The whole bench is going. I might have to rotate the printer a bit so that the bed movement doesn't destroy the desk. I've got to hold the desk down. Holy bananas. Holy moly. There's some weird clicking noises going on. I don't know where that's from. It's not like... Oh, it might be the end stop lever wobbling. Luckily, should we need it, we have an old friend to help. Mr. Fan. Just increasing the acceleration to 20k, a nice round number. We're also hitting our max 400 millimeters a second velocity. I feel like we might be a little bit under lubricated for the rails. So bonkers. Yeah, I'm not sure what it is it's clicking. It sounds like when like a cooling duct catches on a bit of filament that's like pointing upwards a little bit. It sounds like that kind of plastic scrapey sound. I'm not sure. Still need to go significantly faster. Thanks, Paul. I mean, I've not actually turned the fan on yet. This fan's still off, so it's not doing anything yet. I'm just going to blow a load of dust out probably the first time I blow it on, so I'll turn it away for a bit. Any dust that's going to fall off away. God, it's windy in here with that going. Funny that. $8:13. God, 5 minutes 33 is bloody fast, isn't it? Don't disconnect from the build plate, please. This is going to still be like 12 minutes, which is what the thing estimated. somehow. Considering it's going completely different speeds and accelerations to what it thinks, that's a very good estimate. Square corner is at 50 at the moment. Layer height is 0.2, I believe. I can't remember what the limits. Ooh, bloomin' Nora. Poor desk. Jesus. What was I going to check? Layer heights. .25 layer heights. Yeah, 0.25 is what I got. Let's get square velocity to 10 or 5. Why? That means slowing down. I'm not trying to make it look good. "11 minutes. Oh, 5 to 10 higher. Okay, that makes more sense. We can probably push it a bit higher than that. Oh, it's very, very stuck. So stuck that... Oh, we're going to pull the Benchy apart getting off the bed. Oh, it's got the brim, I think. Why did it have a brim? Didn't I turn the brim off? It's got a brim. I do not need brim. Bye-bye, brim. Brim, brim. So, yeah. Pretty happy. 11 minutes and 7 seconds. Zoom, zoom. Boaty boat. So that's 11-minute Benchy without any cooling. That's pretty reasonable. Okay. So, settings. So the slicing settings are going to matter less and less because I'm controlling it mainly with the panel on the printer itself. So we just need to set the speed such that it's so high that we're not going to reach it. So we put these at like 800 or something. And then we could just control the actual max speed with the printer interface. So that's still going to say 12 minutes, that's fine. It is, where has it gone? Yeah, 800 millimeters per second. Can't use bigger layer heights for speed benches. It's got to be within the rules. I know it seems daft having rules for printing boats super quickly, but believe it or not, there are rules. So let's send that off. I don't think we needed... I did the brim. I think now it's just take these settings and just pump them up and up and up. Well, mainly this, I think, and this. This needs to be the same as this for a start. Oh, Benchy's still on the printer. Infill should be regulation. 15% grid. Infill is also set limit-wise percentage words. I think prismatic is maybe a little bit faster. Thanks, Paul. I wrote them down from when you sent it just now. Thanks for sending those. I'll be trying to get towards those. Acceleration to deceleration. I mean, the default, I believe, is to have them the same. So there's no reason not to. I suppose the other thing to check is... Oh, it's going to go. Oh no, it's just doing that. Is... Steppers, LVO. 1684. 2209s. Oh my Jesus. Yeah, so it's a low 1.188. I don't know how much we can push those. I'm not sure Z needs 1.188 if that's like high, but Z's not really doing much. I don't need to clean the bed. It's clean enough. It's brand new. I've done literally like 2 prints. Alright, let's go here. I'm hoping as long as I bump the acceleration enough, we should get down to somewhere around 8 minutes this time. So I'm literally going to be playing with acceleration and this. I want both of these the same. Please change. I don't know why this doesn't want to change. You have to click it to increase. That's weird. Oh, it can't be higher. What the hell? Don't know why this won't accept new values properly. Yeah, I thought it was, because it's probably sending loads of G-codes to change it. Yeah. And that's going to get super confused when I start printing. Yes, boy. Now we're talking. Oh, I forgot to start the timer and the fan. The temperature's already pretty hot, it's at 260. I don't think there's much point increasing temperature until we're having real major extrusion problems, which I suppose we are, but flow rate is hitting 40 cubic millimeters a second, but obviously it changes every fraction of a second, so it's hard to tell what it really is. It is a lot, but it's literally for the tiniest fraction of a second. Oh, blimey hell. Did you see the mouse move on screen then? That was all the printer. Oh, it's chucking bits of plastic off left, right and centre. It doesn't have the same cooling issues. Because it's in, I think because it's open and because the bed is moving backwards and forwards, it's like brushing itself with air as it moves. Oh, thank you for timing. I don't think it's going to be that fast. Oh, it is really moving now. It's struggling to support its own weight. That Z motor is incredibly hot. Wow, it's sliding a lot. Try and just catch it in the edge of the airflow. You can see this part. Maybe if I try and turn it a little bit. You can see relative to this, which is staying still. It's less obvious on camera because the table's moving as well. It's moving all over the place. What happens if I try? I mean, it's not going to change the speed of the print. That's 27k on acceleration. That's 30k. No, it's not. Sometimes it holds and sometimes it doesn't. There you go, 30k. Square corner up to maybe 85. It's just moving so much. Can't keep control of it. It's just wandering off the table. It's moving all over the shop. I can't stop it. I don't think I... Ooh, I do have a soft rubber mat. I don't know if it'll help. It's not very flat either. I think it might be just as slippery, to be honest, because it's not very clean either. Shake your boaty. Don't shake your boaty at me. Oh, look at it go! Oh, it's insane. Well, bed slingers aren't fast. You can't print fast on a bed slinger. Bullshit. Can now. The amount of movement is absolutely ridiculous. I'm holding it and I can't even keep it still. Okay, 821. Oh. No problems with bed adhesion though. So it's probably what, like 8:30, something like that. See if I can get this under the bed in a way that's going to help it. I'm not sure why it's going to be any different, but 850. some clamps. I've got clamps. I need an edge or something to clamp them to. VHB into the table. Let's keep the printer hot. Turn this off. I'm going to try this first. It might be better, it might be worse. Or put it on the floor. Yeah, and then it can't fall off the table. Carpet on the floor though. Floor is actually not a bad idea. Or just a different, no, it's just going to be a different table surface on the floor. It's just going to have the same problem. Rubber feet on rubber mat, but it's not... But it's still rubber on table, which is not that grippy. See you, John. Thanks for joining. I shall see you soon. So we're going to reprint this again. Bye bye, John. Bye bye. 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 Don't forget the clock. I've forgotten the clock. Where is the clock? It's got to do homing first, isn't it? Or has it done that? I've forgotten what it's doing. What are we doing? What are we doing? Where are we going? Okay, we've got to do all this malarkey. I think this is why I forget it, because we've got to do all this other stuff first. If we don't stop the table moving, the whole electronics box will end up on the floor, which we definitely don't want. This seems reasonably grippy. I don't know if it'll be enough though. Might be a little bit quieter. I could increase the hot end temperature a little bit. Because it's probably not at temperature anyway. Although if it probably... We'll see. I'll try and monitor. Remember like a couple of minutes into the print to check the temperature, and we'll see what it is. Because if it's staying at temperature, increasing it more probably won't help that much at 260. Could though. We'll have a go. It's at 150 Celsius. It was 265 on the VCNI. I'll change the 270. Okay. So let's put acceleration up. 35k. Gonna have to do it after the print starts. Clock, the clock, the clock, the clock. Clock, 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 clock. $250. $260. Right. Moving. Squeeging. 3, 2. Gotcha. Right, so increase the height and temperature to 265. The neighbours are going to wonder what on earth is going on. Whoa, it's just spitting filament off. Something just, a bit of filament just flew out of the print. Ooh, no. That was skipping. I think the problem could be that I've tuned. It's now a different surface to what it was tuned on, so I think it might be. Because of the input shaper trying to adjust acceleration. Some pretty dodgy noises going on. Oh, the Y skipped again back to the original position. Not enough cooling. Do you reckon I need a bigger fan? Is that what it is? Is this one not big enough? We're hitting all sorts of limits now, I think. Some minor layer shifting. A little bit. Well, yes, it is an invalid Benchy. I would agree with that. But we are still stock settings. Not seaworthy, yeah. Yeah, you're probably right. It's got a bit of a hole in it, hasn't it? I reckon this back part is just going to fly off at some point. You can't see so much from it. I need my trusty Rat Rig advisors, and they're not here. I think the problem is the input shaping for Y. We've invalidated the setup. We might have to just, well, I don't know, as any time that I'm holding it or controlling it is going to have problems. Maybe we turn off input shaper. I can't remember if it's better or worse. Ooh. Yeah, that was max acceleration and it didn't manage that. Oh dear, we've had a disaster. The flow rate goes up to like nearly 50 cubic millimeters a second. Lots of people are joining. Success! Oh dear. $7.57. It's got to move such an enormous bed, isn't it? 757 and not valid. I think it's just too much weight. We could try longer, but it's been nearly 3 hours now and I'm kind of exhausted. So I think we're going to call it a day. I might try another day though, so stay tuned because I'm going to see if I can get some more data on motor currents and stuff, and we'll see if we can push currents for the y-axis up a smidgen, see what the limit is, because if we can get more force, we can get more acceleration, and then we can more boosty. But yes, probably not going to be printing those settings 24/7. It's a little bit messy. Literally, stuff was just flying off the prints. Bits of filament just everywhere. But you know, sub 10 minutes, 850 was I think the fastest successful one. I mean, successful. Depends on your definition. But for a speed Benchy, it was all good fun. Right, thanks very much everyone. Don't forget to use the voucher code if you want to buy one of these absolute monsters. There's one for mechanical kit or the full kit, and then my divider PCB, which is like the add-on board which I'm using, which helps if you want to disconnect the printer in the electronics box, as well as for like maintenance and upgrading and stuff like that. And calibration flour. Get yourself calibration flour. I've got no link in the video description, but if you look up calibration flour, this should appear. And that's what I use to calibrate this and measure the skew and dimensional accuracy. Well, on lots of things, but also I did that today. Thank you very much, everyone. I shall see you again soon, if I remember where the button is. Bye.